Hi everyone, welcome back to Aviation Tips, and whoever's new, welcome to this channel. This topic is about the auxiliary power unit, aka APU, which the panel is located in the overhead. It's a pretty simple panel, just the power fuel switch and the start stop switch. The APU's primary function is to operate the accessory gearbox mounted 30 kilowatt generator. And the secondary function is to supply bleed air for air conditioning and engine starting. The maximum operating altitude for the APU is 37,000 feet. The APU's RPM does not vary. It will stay constant at 12,000 RPM to maintain frequency of 400 Hertz. APU is located in behind the aft baggage compartment, and it's roughly around here. What the ECU, electronic control unit, monitors all the APU operations. And the ECU is DC powered. Maximum altitude to start the APU is 30,000 feet in CRJ 200. The altitude to start to use the APU bleed air would be 15,000 feet. And the maximum altitude to start an engine with APU is 13,000 feet. These are the limitations that you have to memorize. Excuse me. And the APU intake is basically right here, located on the upper left rear side of the fuselage. This is the door. It's kind of a weird looking door, but it is what it is. APU door have 3 positions: open, mid, or closed. The position is determined by the electronic computer unit, which is ECU, and is based on the aircraft altitude and true airspeed. If the APU door actuator fails and the door is not operable, the maintenance can only mechanically position the door to any of the 3 positions. And the aircraft can still fly if the door gets stuck. And limitations are applied. The airspeed limit for it is 300 knots for CRJ 200. For CRJ 7 and 900, the limitations are roughly, I think, 220 knots, I believe, which is pretty low. The exhaust, APU exhaust, is on the right side under the engine, almost at the end of the engine there. Under the exhaust danger area is roughly 15 feet. So when they do a walk around, if the APU is on, they gotta come up, walk semicircle there. It's danger area, pretty hot. The APU has a self-contained lubrication system. There's a gearbox mounted oil pump oil cooler assembly, and integral oil tank. There's a screen duct on the left rear fuselage. I don't think it's shown here. Right up here should be. The air is drawn through the screen by an APU gearbox driven fan to provide APU oil cooling and ventilation of the APU enclosure itself. And it would be somewhere around here. But in this, I guess explain 11, they don't have it here. So it should be somewhere around here. The APU itself receives fuel from both wings, both main wing tanks by the APU cross-flow pump, which if you guys can, let me see if I can pull up the fuel. There's a pump right up here, so it pulls from this wing and this wing and receives fuel. APU uses normally approximately 120 pounds an hour with electrical and bleed air loading, which means everything's on and you have the environmental controls on to ECS. If the cross-flow pump failed, in case of that pump fail, APU will receive fuel via the APU negative gravity relief valve, which is pressurized by the right engine fuel feed manifold. So it should be one of these lines that would just it's a gravity fuel flow that would come to APU. The APU SOV valve is right up here. It is used to control the fuel supply to the APU. And APU SOV is opened by pressing the power fuel switch light on the APU control panel, which I showed you guys right up here. This is the APU power fuel switch. As soon as you press that, you open the fuel. Let's see if we can stop this and shut down the APU. It is. See if we get any difference there. What's going on with that? Is it shutting down on me? Or what is it? Yeah, the APU is closed now. I feel like we're gonna. The door is working. There you go. It just closed. Well, at least that works. You guys could see. And as far as the fuel goes, there you go. So it does eventually close. So as soon as you press that, SOV closes or opens up and sucks the fuel from that pump. Obviously, how do you when would this open or close? By pressing the only thing that you could close it. To open it, you just press power fuel switch there on the EPU panel. To close it, pressing power fuel switch or APU fire push, which is located, should be located here. That's engine. Where's my APU fire push? Yeah, the APU fire push, one of these. Oh, that's a master. I don't think this has, or it has a horrible graphic, and you should have an APU fire push switch around here, so you press it and it will close the SOV valve there, or it will close automatically when the APU fire is detected. That's another thing. So either you press the APU fire push, or it will automatically detect and closes the SOV for APU. Let's just turn it back on. Let's see what happens. When you turn it on, a couple of things you will see: APU, SOV, and byte, and APU. There it is. Now it's open. Now we just press start, and it's gonna. So that's pretty much open there. There's another SOV. The SOV that's located between the APU of FCU and the fuel nozzle. That's the one that is not depicted on the synoptic page. The solenoid SOV opens when the APU ECU at 4% RPM. The RPM is 4% and it opens. And once the fuel stabilized, the fuel scheduling is once the APU is stabilized, EGT, RPM, generator, and bleed air demand influence the fuel scheduling on the APU itself. To shut down APU, I showed you stop and then power fuel. The APU SOV is DC powered. When the APU power fuel switch light is pressed, the APU in-byte status message appears on the status page. Let me see. Let me show you right quick the whole process. Stop. And let's take a look right quick at the APU door, how nice it closes. Take some time to close. There's open. There we go. Perfect. Now let's get inside again. Get ourselves situated here. What do we need to look for is what we're gonna do. Let's say when we press the power APU power fuel switch, what happens? So as soon as you press that, you should see APU in byte, and it should disappear within 5 seconds, which I don't see anything here. And then you should see RPM and EGT gauges, which should appear on the status page, which is there. And then the APU intake door opens. There you go, the door is open on the status page, and APU fuel shutoff valve is open. APU SOV open. So APU SOV and APU invite, you should see them right here within 5 seconds. And then one more thing, the APU cross flow APU fuel pump starts at this point. As you guys saw in a minute ago, I showed you guys SOVs open. And then at this point, what we do is just when you start and press the start stop switch light, what happens, we'll take a look at it. There we go. So the APU start status message appears, which we don't have it here, but it should have a message appears, and the start light and the switch light illuminates. Obviously, you had it start, right? Oops, they just turn it off. So the APU start status message appears on the status page, and the start light and the switch light illuminates. The starter motor is energized, which I'm going to show you, but I'm going to read the whole thing. At 4% RPM, fuel and ignition is introduced. Fuel is introduced by the fuel isolation solenoid SOV, and the starter motor is de-energized by the ECU at 50%. As soon as you get to 50% RPM, you get the starter motor de-energizes, and the start and the switch light extinguishes. The green available light in the start stop switch light illuminates at 99% RPM plus 4 seconds. APU LCV open status message appears. So we don't get in here any status messages, but the stuff that I read, you can see, you can go back and rewind the video and see what's happening. So I'm going to start this thing up. So there's the start message. Somehow it was pressed in. There's about 50%, 50%, and the start message disappeared on us, and 90% the available light came up. And on top of that, as I guys showed you here, SOV open, but you should have a status message too, which we unfortunately don't have any status message coming up, just the caution and warning messages. The green light, the green available in APU start stop switch light indicate that APU is ready to accept bleed air loading. The light will come on 4 seconds after the RPMs at 99% or more. So 4 seconds, you get a green available light, and that means it can take loads, ACS and power. The amber light, you might have amber light right up here on power fuel actually switch light indicate there's an amber light right up here. It indicates cross flow APU pump failed. So if you get any amber, the cross flow is down. Alright, the starter limit for the APU, there's maximum time on is 30 seconds, followed by 2 minutes off, and then 30 seconds, then 30 seconds followed by 40 minutes off. So that is the APU battery start limitations. The DC, if you use a DC ground power, then 15 seconds, and 15 seconds, 20 minutes off, 15 seconds, and then 15 second, 40 minutes off. So instead of 30 seconds, you get 15 seconds. The APU has um, two air gap igniter plugs. If it, you know, if you even care about that. For the start of an APU, both the main and APU, the main and APU batteries are required to start and operate the APU. So these are going to electric page. Both of these batteries are used to operate the APU. The APU batteries is used to turn the APU starter, and the main battery is used to operate the APU ECU, electronic computer unit. The voltage to start the APU, battery voltage to start APU is a minimum of 22 volts. So if you see 22 volts below that, it is impossible. I mean, there was a situation that we started below 22, but it is kind of a that's the standard for the CRJ. 22 volts, that's the minimum. When you are in flight, it's a little bit different. Let's go back to this. When you're in flight, the reason you have to press power fuel, and start within 5 seconds is because APU door will open, and if the APU is windmilling at the speed greater than 8% RPM before pressing start switch, the APU starter will not engage. This is due to the APU ECU inhibit logic, basically. So you got to be within 5 seconds before it's the APU will start windmilling. That is important to know. If the APU is stopped, we need to give it about the ECU basically initiates a 60-second byte test. This test must be completed before the APU can be started again. So let it do its thing for 60 seconds at least. So when the available light is start stop switch light extinguishes, a better practice is to wait until 10% RPM to press the power fuel switch to deselect, basically to deselect the power fuel. So wait about 10% RPM until 10% RPM, then press the power fuel deselected. As we mentioned before, the cranking attempts of APU, the time wise is 2 minutes because it's allowed ECU to reset, so 60 seconds, but we'll just give it a 2 minutes total. So the APU automatically will shut down on the ground and in flight. So I'll tell you, um, if so, APU fire detects. APU detects fire. It will shut down itself on the ground and in flight. If there's a slow start, engaged more than 60 seconds, it will shut down on the ground in flight. Over speed, RPM greater than 107%, it will shut down both on the ground and in flight. If it loses DC power on the ground in flight, it will shut down. RPM signal lost, yes, on the ground in flight. EGT signal lost, on the ground, yes, and in flight too. ACU failure, on the ground and in flight. Low oil pressure on the ground, yes, it will shut down itself. In flight, APU control logic reverts to the ground mode 60 seconds after landing. High oil temperature on the ground, it will shut down, and in-flight APU control logic reverts to the ground mode 60 seconds after landing. EGT over temperature, on the ground it will shut down. Again, in flight it will reverse to ground mode 60 seconds after landing. Intake door position signal lost on the ground, it will shut down. In flight, reverse to 60 seconds after landing. An electrical short detects on the circuit or current on the ground, it will shut down. In flight, the APU control logic reverts to the ground mode 60 seconds after landing. So there's the APU variable geometry diffuser. That is basically is variable geometry diffuser that is used to protect the compressor from surging or stalling, and is controlled by the APU ECU. The vanes which are located at the compressor discharge are open to increase the flow of air through the compressor and closed to decrease the compressor airflow. The need for a different airflow amount is due to the electrical and bleed air loading of the APU. Alright, so we gone through the primary function of the APU. Can the APU itself can be shut down from the outside. There's a remote cutoff switch located on the external service panel, and it's an aft equipment bay on the APU too. So there's two of them, I think. Yep, two of them. One an aft equipment bay, one is the service panel, which is where you can open the nose gear door. That's where you can find that switch. For some of you who don't know, it would be right up here. Some of these ground personnels, they can open this panel and just shut down APU somehow for you. and you don't even know it. Since your engines are running, the APU shut down, and it's kind of a weird situation at that point. And there is a warning horn will alert ground personnel, but sometimes I don't know, it's too loud for them to notice because the engines are running. If the engines are running, if not, then if one engine is running, then it's pretty hard. But if two engines are running, then it's kind of it's very hard to figure out that way. If there's a APU door, if the APU door is unknown by the APU ECU, the ICAS will show a white door message with amber dashes on the ICAS. You will see right up here, it says door, and it's kind of a caution type of amber type of, and then you see dashes. It won't say open, closed, or mid, something like that. The APU RPM ranges, you will see a green from 0 to 100, amber 101 to 106%, and red 107% and above, which will cause an automatic shutdown as soon as you reach 107%. AGT range of APU is 0 to 712 degrees. It's normal, that's green. And if it goes to the amber one, 713 to 742 degrees, and then red 743 or greater, or 974 degrees, less than 50% during start. Those are the ranges for the gauges when the APU is operating. Well, that's about it. I hope you guys enjoyed this video. This is Explain 11. I pulled it from Delta Connection there. CRJ 200. They didn't have any CRJ 200 in MSFS, Microsoft Flight Simulator, so this was pretty useful. So we saw most of these gauges, but the status messages are lacking. We don't get any of those, which it's okay, not a big deal. Yeah, I hope you guys enjoyed the video. Please thumbs up, subscribe. This is just a livery of Delta, as you guys can see. I just picked random livery. It's Delta. Yeah, it's pretty nice livery from outside, but when you go inside the aircraft, the graphic is not so great. Yeah. Alrighty. Have blue skies, tailwinds, and see you on my next video.